Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Dogba Jr., your math tutor. In my today's lecture, I will be discussing differential equation, the continuation of our lesson from last lecture. So in this lecture, we want to solve the first example problem on a variable separable. So we told you when it's possible to separate the variables in a differential equation, that is all x variables on one side of the equation and all y variables on one side of the equation, then you can apply variable separable method and find a general solution of that differential equation. If that is not possible, you can also test as to whether you can reduce it to variable separable. If that is also not possible, then you can use other methods like homogeneous, like integrating factors, whatever method that fits with that particular problem that was given to you. So the first example says that we must find a general solution of dy by dx equals to e raised to the power x plus y plus x squared e raised to the power y. So go ahead to solve this problem. Now we have our dy by dx. So what we can do is we can first get rid of this dx by dividing both sides by dx. So if we divide both sides by dx times this one is just dy, and then dx times this expression. Now, mind you, this e raised to the power x plus y can be rewritten as e raised to the power x times e raised to the power y, because when the bases are the same, you add your powers. So plus x squared e raised to the power y. Then we just attached the x to it because this dx must be multiplied by the left and by the right. So we have dy equals, now we notice that there is a common factor, which is e raised to the power y. So e raised to the power y comes outside. You're left with e raised to the power x plus x squared. So now since we are wishing to separate the variables, that is in this entire factor, all of the variables in there should be x, and this factor, the variable here, should be y. So since the variable here is only y, we can send this e raised to the power y on this side of the equation, thereby dividing both sides by e raised to the power y. So e raised to the power y will cancel. Now we'll be left with dy all over e raised to the power y equals e raised to the power x plus x squared dx. So we clearly see that we have an equation that have separated all of the x, from all of the y. So all of the x on the right hand side of the equation and the y expressions on the left hand side of the equation. Now we can integrate. So the rules here, we should integrate both sides to find a general solution. Now we know that the integral of e raised to ax dx is just equal to 1 over a e raised to the power ax plus some arbitrary constant c. So that's one thing we know. So we want to apply that method here. Now we do not have an integral formula for e raised to the power for the integral of dy by e raised to the power y. So what we need to do is to send this e raised to the power y in the numerator. So we can say the integral of e raised to the power minus y dy. So when the power is leaving from the denominator now, when it is going to the numerator, it changes to negative. So we have equal. Now we can integrate. E raised to the power x is just like the coefficient here is 1. So if we want to use that method, which is 1 over a, now it's just 1 all over this coefficient. So it's just 1 over 1 e raised to the power x plus. Now the integral of x squared, we know that the integral of x raised to n dx is just equals to x raised to the power n plus 1 all over n plus 1 plus some arbitrary constant c. So the integral of x squared is just x raised to the power 2 plus 1, 3 plus some arbitrary constant c. Or we can first integrate this one before we attach that. So the integral of this one now is 1 all over negative 1, because the coefficient is 1, e raised to the power minus y equals, now this is e raised to the power x plus x cubed all over 3 plus some arbitrary constant c. So if we send this term across the equal sign, if we send it across the equal sign, we will have e raised to the power, positive e raised to the power, because this is now negative. So when it goes across, it's like saying negative e raised to the power minus y. So when it goes across, it becomes positive e raised to the power minus y. And then if these guys come across this sign, if they come on this side of the sign, you're left with negative. But we don't want to go that route. But even if we don't go that route, we will still go, because we want to solve for this y. So we still have to do it. So now we have e raised to the power x plus x cubed all over 3 plus some arbitrary constant c. Now if you have x equals to 3, it means 3 is equals to x as well, right? So if we have this equal to this, it means this is also equal to this. So we can say e raised to the power minus y equals to minus e raised to the power x plus x cubed all over 3. Now this is minus, right? This is minus, or minus. So now if we want to solve for y, not just e raised to the power y. So we know that e raised to the power y, if we take the ln of it, is just equal to y. So we know this property of natural logarithm. So we can take the natural logarithm on both sides. E raised to the power minus y equals the ln of minus e raised to the power x minus x cubed all over 3 minus c. So now the ln of this one is just equal to minus y, right? So this one now will be the ln of, so this expression now is minus e raised to the power x minus x cubed all over 3 minus c. So we divide both sides by minus, or we multiply the entire expression by minus. It means we will have positive y equals negative the ln of minus e raised to the power x minus x cubed over 3 minus c. So this minus that is here now can affect, because the rule says r ln of a is equals to ln of a raised to the power r. So whatever coefficient is attached to this ln, now here is just minus 1. So if we send it up, it will be y equals, so let me carry up. Let me take it here. Okay, so if we send that expression up, we will have y equals to now ln of, so put that expression in parentheses, minus e raised to the power x minus x cubed all over 3 minus c. And then this minus 1, we send it to this power. So we know that when the power is negative, we can reciprocate. So this now becomes ln of 1 all over. Now, this negative c, we told you the c can be, c is just c, the constant is just a constant. So without negative c, positive c is just c. So we can rewrite the c as positive c. Because since it is positive now, I want to bring it first. So I write positive c minus e raised to the power x minus x cubed all over 3 is our final answer. Or we can further simplify. Yeah, sure, we can further simplify, because we don't want the problem not to be simplified in a simple form. But this problem could also end right here. Your instructor could ask you to just keep this as your required answer, but I would just want to simplify it further. So look here now, there is a denominator here which is 3, and then so you can express these guys over 1. So y now equals to the ln of 1 all over. Now down here, now we can find the LCD, which is 3. 1 goes into 3, 3 times c is 3c, minus 1 goes into 3, 3 times this is 3 e raised to the power x. And then 3 goes into this, 1 times x cubed is s cubed. So this 3 down here goes in the numerator. So you have y equals to the ln of 3 all over. Now this 3c is just the same as saying c, because it's just a constant, so we just say c. Minus 3 e raised to the power x minus s cubed. So this is our final answer. This is the answer that we want, but you can stop here as your final answer. So thanks ever so much for watching. Please subscribe to our YouTube channel. See you in our next lecture. Thank you.